writing ionic compound formulas. Before we get going, let's just recall that the net charge of an ionic compound is 0, meaning ionic compounds are neutral, and therefore the total number of positive charges from the cations must equal the total negative charges from the anions. And then we'll use subscripts to indicate the ratio of cations to anions in a compound. That just means we'll use subscripts to tell us how many cations there are and how many anions there are in one compound. There's 3 steps for writing ionic compound formulas. First thing we'll do is write the cations and the anion symbols with their charges. Then we'll balance the charges, and then we'll write the formulas using subscripts as needed. So let's take a look at the first example, sodium chloride. We look up sodium on the periodic table, and we'll see that it has a symbol of Na and a charge of 1+. So we'll write that down. Symbol is Na, and the charge is 1+. We look up chloride on the periodic table, and the symbol is Cl, and the charge is 1-. Then we balance the charges. Well, if Na is 1 positive charge, let's list the positive charges. We have 1 of them. And let's list the negative charges. We have 1 of those. So we can see that there's only 1 sodium ion and only 1 chloride ion in this compound, so our formula will just write it as NaCl. Let's take a look at the next example, aluminum chloride. Aluminum on the periodic table is Al, and it has a charge of 3+. Chloride we already know is Cl with a charge of 1-. So let's list out our positive charges. For the positive charges, we have 1 charge of 3+ per aluminum ion, and for Cl, the negative charges, those are worth 1 apiece. So we can see that we'll need to have 3 chloride ions to equal the same amount of charges as the aluminum ion. So therefore, what we have as a formula is 1 Al and 3 Cls. So our formula would be AlCl3. Next example is calcium nitride. The symbol for calcium is Ca, and it's got a charge of 2+. The symbol for nitride is N, and that has a charge of 3-. Let's look at the positive charges. 1 ion of calcium has a charge of 2. On the negative side, one ion of nitride has a charge of 3. So how do we get these two? How do we get the positive and negative charges to equal out? Well, let's see what happens if we add another positive charge. 2 + 2 = 4. That still doesn't equal the negative charge of 3. Let's add a charge on to the negative side. An ion, to the negative side. So now we have 3 + 3 = 6 on the negative side, and 2 + 2 = 4. I think then we can add another positive ion, and we'll have a total positive charge of 6, which equals our total negative charge of 6. How did we do that? Well, we have 3 calcium ions, and 2 nitride ions. So our formula will be Ca3N2. Now let's look at the case where we have multivalent ions, and it's the same thing here. We have nickel 2 and we have chloride. So first we'll look up the symbol for nickel, and that's Ni. And the Roman numerals there indicate to us which charge of nickel we're talking about. So we're talking about nickel with a 2 plus charge. Chloride, we already know, is Cl, and it has a 1 minus charge. And so let's count up the charges. On the positive side, we have the nickel. One ion of the nickel has a charge of 2. And on the negative side, one ion of chloride has a charge of 1. So we'll need to add another chloride ion to make that equal the same amount of charges as the positive side. So our formula should be Ni, there's only one of them, and Cl, 2, because there's 2 Cl's for every 1 nickel. Copper 1 oxide, the symbol of copper is Cu, and the 1 in Roman numerals means we're dealing with copper with a +1 charge. Oxide, the symbol is O, and the charge is 2 minus. So let's try balancing the charges. On the positive end, we have one charge of Cu, one ion of Cu has a charge of 1. One ion of oxide has a charge of 2. Therefore, we'll need to add one more ion of copper 1, for it to equal, for the compound to have the same charges, same positive charges as negative charges. So our result should be Cu, there's 2 of them, plus the O. So Cu2O is copper 1 oxide. Next is chromium phosphide. Chromium has a symbol of Cr, and the Roman numerals there indicate that it has a charge of 3 plus. Phosphide is P, and it has a charge of 3 minus. So one chromium ion with a charge of 3 has the same amount of charge as one phosphide ion with a charge of 3. So we can write that as CrP. And finally, we'll cover the case where we're looking at ionic compounds with polyatomic ions. So we just have to recognize here that there are polyatomic ions. Calcium nitrate. We'll start with the cation. It's calcium. Symbol is Ca. Charge is 2 plus. Nitrate is a polyatomic ion, so I'll look that up on the polyatomic ion table, and that is nitrate with its NO3 is the symbol, and it has a charge of -1 or 1 minus. So on the positive end, there's only one ion of calcium has a charge of 2. One ion of NO3 has a charge of -1. So we'll need another ion of NO3 to equal the positive charges. So our end result is Ca and then NO3, and because there's 2 of them, we'll put the NO3 in brackets and put a 2 as a subscript. So Ca NO3 2. Looking at tin 2 sulfate, the symbol for tin is Sn, and the Roman numerals indicate that we're dealing with a charge of 2 plus. Sulfate is a polyatomic ion, and the symbol there is SO4, and it has a charge of 2 minus. So here, one tin ion with a charge of 2 cancels out completely with one sulfate ion, also with a charge of 2. So we can just write that as is, SnS04. And we don't need to put any brackets or parentheses around SO4 because there's only one of those ions there. Looking at the last example, ammonium sulfate, ammonium is a polyatomic ion, and its symbol is NH4 with a positive 1 charge. Sulfite has a symbol of SO3, and sulfite has a charge of 2 minus. So if we balance that out, one ammonium ion has a charge of 1. One sulfite ion has a charge of 2. Therefore, we're going to need to add one more ammonium ion so we can have as many positive charges as negative charges. So our formula, therefore, should be NH4. Since there's 2 of those, we'll put that in parentheses and put a subscript of 2 there to say there's 2 ammonium ions. And there's only one sulfite ion, so we'll just write that name as is. And that is how to write ionic compound formulas.